what I want to talk about today is platforms, right? That's why you're here, developer platforms, whatever, internal developer platforms, whatever we call them. And specifically, I want to talk about consoles. You know, that's depending on who you are, console. When I say console, I mean front-end user interface, the thing that people interact with. For many of you, that might be what you think is the platform, right? Platform is a console. You install Backstage and you have a platform, right? If that's what you're thinking, you're terribly wrong. And that's the conclusion of this talk, right? And so let's go for it. Introduction. I'm Viktor. This is me when you ask me questions. I work for Upbound. I have a Twitter account, blah, 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 blah. Doesn't matter. And I have a setup for slides because I will do a demo, so you can reproduce everything if you go to slides. So when we build platforms, more often than not, what people do, unfortunately, is that they take all the silly things that you have right now in your system, I will call it poop, and then you create a front-end user interface thinking that that will somehow mask that poop. I'm not allowed to say S word, right? Poop, I don't know. Wrap it in it, and it doesn't smell anymore, right? It's so nice now. Look at it. It's nicely packaged, and we all love it. And that's usually not true, right? If we want to build platforms, we need to redesign how we do things. And big part of that redesign is how we approach user interfaces. And actually, there is no mystery how we approach user interfaces, because if any of you is a front-end developer here, you all know that user interfaces are relatively simple and straightforward because they do not contain logic, right? You don't put logic into user interface. You don't tell it what to do, when to do it. You don't create endless number of forms, you know, with fields and buttons and stuff like that. What you typically do is you have a backend, you have an API, your user interface goes to the API and asks, what can I do, right? I can create a database, excellent. What is the schema that I can use to create a database? This is the schema, excellent. Let me paint it on a screen. And that's about it. That's what they do, right? They take schemas of APIs, of your APIs, however you're building those APIs, they use those schemas to transform them into dynamic fields and forms and whatever you have. And they submit the data that you put into forms somewhere. In my case, that would be Git, most likely, right? Because you're all using GitOps. And we use them afterwards to observe, right? So because then those user interfaces are going to those same APIs and say, OK, give me the information about this something, right? That's all they do. There is nothing else we need to do when consoles are concerned. Get the schema, paint the fields, perform some actions, load the data back from where it came from, and show it on a screen. And that's what I'm going to do today, right, in a demo. I don't like talking too much. So I'm going to show you one possible. I will use some tools. Don't think of those tools like, oh, I have to use this or that. I just use tools that I'm comfortable with. You can replace the logic is what matters really here. You can replace those tools with whatever you want. So how we're going to do that? First, I have here, I'm using Port. Again, you can do it with any other user interface you want, right? Doesn't matter. What does matter is that here in settings, I have configured already saying, you know what? I'm not going to tell you what to do. I'm not going to inform you or design anything. I'm not going to do anything. The only thing I'm going to tell you is there is a Kubernetes cluster over there, and I already extended that Kubernetes cluster with services. I have a custom resource definition that defines how I deploy applications. I have a custom resource definition that defines how I manage databases, and I have a CRD for managing Kubernetes clusters, right? It's just custom resource definition in Kubernetes. Everybody's using Kubernetes here, or what's wrong with this country? You should have stopped me earlier and say, go away, we like mainframes. No? Okay, anyways. I'm telling, go to my Kubernetes cluster, get all the custom resources, get all the endpoints, filter them, because I don't want to show everything to everybody by using the kind composite resource, whatever it is, only those that are namespaced. Cool. I press a button, and now it is synchronizing, right? It is getting information from the APIs, from, in my case, Kubernetes API, to find out what it can do, right? That's the only, I'm not going to design anything else in this user interface. I just told it, go to my API, find it out. And the result of that are those things, right? It figured out that, okay, there is something called upclaim. This tool has no idea what it is, but it knows that there are some fields over there, because that's a schema coming from the API. It knows that users might want to fill in those fields, and so on and so forth, right? And it automatically generated some services, meaning that, hey, I know, depending on that schema, on that API, that I can create something called upclaim. I don't know what it is, but I can create it. I can create something called cluster claim. I can create something called SQL claim. And I can update those things, and I can delete it, right? So my effort, really, and bear in mind that I'm assuming that you designed your services already, but from the front-end perspective, from console perspective, the only effort was literally a few seconds telling it, there's Kubernetes, go and ask it what you can do, right? And now, I cannot use it right away as it is. Sometimes you need to fine-tune things. Sometimes you might need to go here, for example, and say, let me do JSON, because nobody likes fields, right? And I'm going to say, hey, this field that is disabled by default, why don't you enable it? Right, so I'm fine-tuning now the experience. And I'm going to save it, and let's do a bit more. Let's say that, where is it? Backend here. No, let's modify this first. Let me just see user form. Actually, exactly. This is cool, this is cool, this is cool. Composition ref name. Sorry, I got lost for a second. Where are you? Yeah, this should all be fine. So the second thing I will do is tell it, you know what, whenever somebody wants to create something, this is the GitHub organization, we want to push something to Git. This is the repository. Which repository I used? I forgot already. I have it in notes somewhere. Wait. Yeah, port CRD's demo. That's the repo I created in advance. And I'm going to call it GitOps YAML. So take that information from Kubernetes cluster, paint the fields to the end users, and send it to this Git repository, right? To get those GitHub actions. And that's it. That's all. The only thing I'm going to do. I'm going to save it. I'm going to do the same thing with the delete claim. What did I say before? Farcic repository port CRD's demo. There we go. GitOps.yaml. Cool. And I'm going to do that for the third one as well, just so it doesn't feel lonely. There we go. Organization with Farcic. Repository port CRD's demo and GitOps YAML. Right. So that's all. I created everything the developers need to work with, to manage databases, to manage clusters, to manage applications. And now I give it to them, and they can do something like this. They can say, hey, I want to create a database. I'm going to give it an ID, MyDB. I'm going to give it a name, MyDB as well. Namespace, A-team, for example. Size, medium, there we go. And the version, which version should I put? I don't know, Postgres, I think it's 14. Let's say it's 14. 12.6, I think. And it doesn't matter. And execute, right? And that's it. Now, a couple of moments later, you will see here, it will appear in this screen. You will see all the information. My database will be created in AWS. It will be, some things will be created in my cluster, and so on and so forth. Now, the question really is, how did I do all that, right? How did I create this? I mean, user interface, you saw it, that's easy. How did everything else happen? And fortunately for you, I have very strong artistic capabilities, and I draw it all for you. So what I really did, when I showed you that process, I already have Argo CD. Everybody has Argo CD unless you have Flux. I have GitHub, because Bitbucket is not a thing anymore. And I have a Kubernetes cluster. In this case, I have installed Crossplane. Now, Crossplane is a tool that allows me to extend Kubernetes cluster and to create custom resource definitions like those that you saw, right? And to define what will they do. In this case, create something in AWS or create something in Azure and so on and so forth. And so this Crossplane created custom resource definitions, right? It created extended Kubernetes API with whatever I need. Then I told port, go there to that cluster, find out what those things are. Don't ask me questions, just create those fields, right? All those fields that you saw before, they were auto-generated. And when a user comes and interacts with port or any other user interface, it should be trivial to design it yourself. The only action that it will do is that it will either create or update or delete a manifest from a Git repository. And that's the only thing it does. It doesn't do anything else. Form, fields, fill it in, push it to Git. All right? And it should be fairly easy. I can show you later the GitHub Actions. Basically, GitHub Actions just takes input, converts JSON to YAML, creates a file with YQ, pushes it to Git, and that's about it, right? And then Argo CD picks it up, goes to my cluster, creates custom resources that are based on those custom resource definitions. In this case, custom resource is called the SQL claim. It can be anything you want. And then Crossplane, then that custom resource either creates or others some stuff in this cluster or in some other cluster, like deployment services, ingresses, whatever you're doing, doesn't really matter. Or it creates some things in cloud. In my case, I think I'm using AWS, or maybe I'm using Azure. I'm using one of those. And you have a database, right? The user experience is absolutely fantastic. You spent eternity building the services because that's the real work, but you spent almost zero amount of time in your user interface. Yet you get user interface that is custom made to do exactly what you want. So behind the scenes, what is happening really? I have notes here, so it looks like that I'm actually typing everything from memory, but I'm not. Let me close this. There we go. So behind the scenes, what is happening is that kubectl gets here this. Now I'm in a control management cluster, right? And you can see that I extended my Kubernetes cluster with stuff like user policy attachment in AWS and subnets in AWS, and there are some Kubernetes resources and some Helm charts and so on and so forth, right? A bunch of all the resources with all the controllers that I need to use my Kubernetes cluster to manage stuff, whatever that stuff is, not only containers. More important than those, because for end users, if I would show this to developers and say, yeah, you can create those things, they would go crazy, right? Because nobody cares. Like, there is no person who is not really, there is no developer, no JS developer that says, I would like to create some subnets and VPCs. Such person does not exist, right? If it does, he's not a developer. He's now, I don't know, DevOps, something, whatever the name is, right? But since it takes like literally almost no time, I created my own custom resource definitions is this big enough? Do you see it well? Complain? I created my own custom resources, app claims, cluster claims, SQL claims. Those are the fields that you saw here. Where was I here? Right, in self-service. Those are the fields that you see here that are designed as custom resource definitions. Now, you, for example, anybody can say, hey, explain to me what appclaims.devops toolkit series.com is and make it recursive, right? Recursive. If I cannot explain, there we go. Right? And this is the beauty of Kubernetes. Everything is based on APIs, and all APIs are discoverable, right? So you can go with kubectl and say, tell me what is the schema of this thing. More importantly for this story is that any user interface that you're building, or any other CLI that you're building, or any Visual Studio Code extension that you're building can do the same. Go to the API, ask it for the schema. And then I build GitHub Actions, right? Now, this is the simplest GitHub action that you will see in your life. Simply take the input from port, take whatever people submitted in that form as JSON, convert it to YAML, extract the kind and the metadata name and the namespace. I'm getting those information only to generate the unique name for the file. That's the only reason why I'm doing it. Store it as JSON, right? If the operation is to delete it, then remove the file. If the operation is anything else, just save the file under that name, push it to Git, and that's the only thing I'm doing. I'm not doing anything else. And right now, if Argo CD did its work, I should be able to pull the changes, and there we go. And you can see here, this is what was submitted to GitHub, right? This is what GitHub Actions created as a file, and this is what Argo CD, hopefully, if it works, discovered. And I should have it, yeah, that's one over there. Now let's take a look at Argo CD. Argo CD 127.001.nip.io. Password is always the same. Never change it. Admin 123. It's easy. And it deployed my SQL claim over there, right? What did somebody said something? Huh? Okay, cool. Now if everything works, closed plane beta, no, let's do it like this. kubectl get managed. You should see that it doesn't work. I messed up somewhere. But imagine that it did work. I mean, what can you do? I was just going too fast. But here in catalog, you should see my database being deployed. There is information presented to the users. That information is also tailor-made so that users see only the things that matter to them and that they don't see anything else. And they live happily ever after. I just realized that I'm speaking a bit faster than I'm supposed to speak. How much time do I have? That's it. That's my presentation. I have 10 minutes for questions. Ask me anything. If I did not panic and go that fast, maybe it would have worked. But the demo works. You have the slides online. Ask me anything. Questions? Yes?
Thanks for the talk. Data annotation is part of this. I mean, you put data annotation on the CRD. Hello? Yeah,
hey.
Okay, thank you for the talk. Data annotation that you use at the beginning to filter out the things that are going to be shown in the UI, is that annotation that you put in the CRDs?
In this specific case, I did not need to put any specific annotation. You could, and that would be a great idea. In this case, no, because I said the kind is composite resource definition, right?
Okay.
So I want all composite resource definition kinds, right? Just as you could specify deployment as a kind or anything like that. But you can filter by annotation, yes.
Okay.
So you can put annotations. You can filter any way you like.
The last thing that you mentioned, that when the resource is created, that you can filter out which components are going to be shown to the user.
Yes.
That's
So here in Builder in data model, so let's say that I take, well, what did I use? This is too small. I don't see SQL claim. There we go, right? This is the model that it got from Kubernetes, and then I could go and edit blueprint JSON and say, you know what, this one, whatever it is, visible false.
Cool.
Right? You can just, so it the logic that is implemented is that it goes and fetches all the whole schema, and then it assumes that those that are required fields are visible by default, and those that are not required are hidden by default, and then you can change any of those properties, right? So basically, there is option also to say, okay, all fields always, which is probably the case. It mostly depends on whether it's third-party CRDs or your own. I will assume that when it's my own custom resource definitions, I want all the fields. Otherwise, I wouldn't add the field if I wouldn't want it. But then you would probably use something like this. I used it with Crossplane, but you would use something like this with, let's say, Knative, right? I don't know if any of you use Knative. Knative is absolutely amazing. It allows you to simplify very, very complex operations, deploying applications mostly as serverless something. Anyways, and then, but since it's third party, it probably has stuff that you want and stuff that you don't want, and then you would disable the fields you don't care about. So the process is almost inverse. Instead of you going there and designing every single field, what it does, it just gives you all of them, and you just say yes or no.
Thank you.
By the way, it doesn't have to be port. You can do the same. You can create your own Backstage plugin that does the same thing. The point I'm trying to say here is that don't waste your time trying to hard code stuff in UIs if UIs can go to APIs and find out what they need to do. That's the point of the story. Anybody else?
All right, sorry if there's feedback. I'm right next to the speaker. Thank you for the talk, Viktor.
Of course.
So you've described to us and shown us what you've called a dumb interface on this, a nice simple one. Could you maybe talk a bit about what this might look like if it was complicated or like clever, just to help me understand a bit more about what to avoid?
So what I'm trying to say here is that user interfaces, it doesn't matter whether it's internal or external, right? You don't make user interfaces complicated, right? If it would be complicated to buy something on Amazon.com, you wouldn't be buying that something, right? Now, complexity you cannot avoid, but you do not necessarily need to expose your users to your complexity. And now comes the critical part. You always design an API so that frontend can talk to the backend, and you always move complexity to server, right? You never kind of, since 2000s, we don't do heavy computations on our machines, on our laptops. They're just dumb machines. I could have changed the title and saying not dumb UIs, dumb machines, because the processing happens in a cluster. So behind that SQL claim, I'm creating subnets, VPCs, I'm creating internet gateways, I'm creating schemas in databases, users. It's really complex, right? But that complexity is in a cluster. It's behind the API. Just as complexity of EC2 is hidden from you, right? You just create a VM in AWS. The same thing goes for developer platforms.
Okay, got you. Thank you. So it's kind of like back, as I was saying earlier, about the product mindset. We want to, it's a product for, just because they're engineers, they're internal, doesn't mean we need to stop caring about the experience for them. We still need to have the same principles of hide the complexity when we can.
Yes.
Lovely. Thank you.
Yes. I mean, now, the real question here when building portals is what to hide and what to show. And the answer is very simple. They are your customers. Ask them, right? Kind of, I would go as far as to say that any team building a developer platform is bound to fail if you don't have a product manager. Kind of that will go and inquire with its customers, what do you need? And then you're going to fail because nobody will like it. But if you're lucky, you will find one person that likes it, and then you iterate, and you find out what's the user interface. That's the only thing that matters. And when I say user interface, if it can be web, CLI, I don't care. anymore. Anybody else? It's fun, yes. Oh, I think you need to wait for the mic. Throw it.
Hi, so yeah, thanks for the talk. So this tool chain sort of seems to be essentially covering the sort of deployment aspect of things.
Yes.
Is there anything it can do around like the next stage of the story, basically like operations, like once it's out there, the application and the stat that's beneath it will surely need some kind of monitoring and maintenance. Does this sort of tool chain
Yes.
fit itself to that scenario as well?
Yes, so, and that's the trick, and that's the, and correct me if maybe I'm not answering your question, but where most companies fail is that you need to have a full life cycle. You need to have security, you need to have observability, you need to have all the things you do. Now, and here comes the tricky part. You cannot use any of the tools that experts in those fields use, right? Because if you give the tools that security CISO people use to everybody else, they say, that's the Spanish version of the reaction. I can tell you in English as well. Same thing goes for observability, right? We use Grafana. We have a huge number of alerts and stuff like that. If a normal person goes to Grafana and says, I wanted a database, Postgres, tell me whether it's working or no. So the real work, and I feel that that's a work where we have some pending things on Kubernetes level to do as a community, is all that information is already available in Kubernetes, right? If you describe any Kubernetes resource, you will see the events. Oh, this happened to a pod, right? Let's say that you're creating a deployment. You will find out that deployment creates replica set creates pods. You will find out what's happening with the pods if you know where to look. A developer creating a deployment should look only at the deployment. And what's missing there, and we are working on it as a community, is two things. First, how to propagate events from the child resources up the stack so that I don't want to go to the pod to find out what's happening with my deployment. I should see what's happening in the deployment itself. And the second thing that is missing, not for long, hopefully, is how to filter the results. I don't want to propagate all the information up the stack. I want to be able to decide this, and this should go up. This should go up but be transformed like this. And this should be transformed into call Joe. Because there is nothing you can do anymore. It's his problem, right? So propagation of events is the biggest thing missing right now to make those things happen, assuming that I understood your question. I hope I did.